Welcome to all of you. Myself Dr. Neha Desai, Assistant Professor in Department of Chemistry, RBNB College, Sri Rampur. So in the last lecture, we have started with the ion exchange chromatography from the HPLC method. In that, we have discussed what is the definition of an ion exchange. Then we have discussed the two categories or two types of the ion exchange, that is the cation exchange chromatography and the anion exchange chromatography. Now, after studying the different types of ion exchanger, the next is the we have to study what will be the influence of the mobile phase on the ion exchange chromatography. Okay, so before that, if you consider the ion exchange chromatography, two types of columns are used, that is the cation exchange column and the anion exchange column. Okay, so cation exchange column and the anion exchange column, these are the two types of columns used in the HPLC method. So what is the most necessary condition for this? That is the cation exchange column and the anion exchange column, they cannot be used for the analysis of very strong acids or the very strong type of a bases. So the most suitable pH range for the analysis of such a compound is in the 2 to 8. So pH should be in the range of 2 to 8 for the ion exchange type of a chromatography. Okay, now after studying the pH range, then this pH range is directly affected by the separation as well as the retention behavior. How the pH of a substance directly affects the retention behavior? That is, the first thing is the capacity or capacity of a column or retention behavior. Capacity of a column or a retention behavior is directly affected by the pH, because pH, it has a direct relationship with the pKa value. So what is the relationship between the pH and the pKa value? That means if you want to analyze the substance by using the cation exchange chromatography, then its pKa value should be 1.5 times lower one than the pH. Okay, so for the cation exchanger, the pKa value it should be lower than 1.5, and for the anion exchanger, the pKa value it should be greater than 1.5. So the pKa value it should be lower than the 1.5, and in this case for the anion exchanger, the pKa value it should be greater than the 1.5 in case of pH. Okay, now after studying this, what we can say, that is the cation exchange chromatography or anion exchange chromatography, it can be used for the analysis of the weak acid as well as weak bases, but the strong acids and the strong bases, they cannot be analyzed because it directly affects the retention behavior, and when it affects the retention behavior, then it also affects on the separation power of the different substances. Now the next part is the what is the influence of the mobile phase on the ion exchange type of a chromatography. So to see the influence, So the cation exchange chromatography and the anion exchange chromatography, it is a function of the following things. So if you consider the influence of the mobile phase, then it affects the ionic strength of a sample ion. Then the second thing is the pH of a mobile phase. Then next is the basic strength of a sample. Basic strength of a sample, then acid strength of a cation exchanger, all these are the factors which affect or influence the mobile phase. So what are the conclusions which can be drawn from this? If you compare the ionic strength of a sample ion, one more important thing is at the same time you have to consider the ionic strength of a counter ion. So ionic strength of a sample ion, ionic strength of a counter ion, then pH of a mobile phase, then acid strength of the cation exchanger. All these are the factors which influence the mobile phase. And the next important thing is what are the different types of conclusions which can be drawn from this. The first conclusion is an increase in the counter ion concentration reduces the retention time. So the first conclusion is increase in the counter ion concentration reduces the retention time. Then the second one, that is if you increase the pH of a solution, then increase in pH it also reduces the retention time. Now after this, the third one is the increase in the pH reduces the retention time. This is possible in case of cation exchanger. And decrease in the pH, it reduces the retention time in case of anion exchanger. So the next conclusion is the decrease in pH reduces the retention time for anion exchanger. Now, after studying this, along with all these, some other factors which influence the ion exchange chromatography mechanism, these are as follows. That means whenever you are dealing with the ion exchange chromatography, then the ion exchangers, they prefer to have an ion with a higher charge than the ion with a smaller diameter. So what are the things that the ion exchange chromatography prefer? This is our next point of interest. So if you want to analyze the substances by using the ion exchange chromatography, then the ion exchange chromatography, it prefers the ion with a higher diameter. Then the second one is, the ion with a higher charge and a smaller diameter. Then the third thing is ion with a greater polarizability. These are the things which are preferred by the ion exchange chromatography. Now the next important thing is you have to consider the retention time. So what is the effect of retention time in case of a cation exchanger, and what is the effect of a retention time in case of the anion exchanger? So whenever you are studying the retention time, then the retention time of a cation exchange chromatography is increased if a counter ion is increased with another ion. So what is the sequence for this replacement, that we will see. One sequence for the replacement of the counter ion in case of a cation exchanger, and another sequence for the anion exchanger. So the next is retention time of a cation exchanger is increased if a counter ion is exchanged with the another ion in the following sequence. So what is the sequence for the cation exchanger? That is barium 2+, then Pb2+, after that strontium 2+, after that calcium 2+, then nickel 2+, after the nickel, next one is the cadmium 2+, then copper 2+, then next is the zinc magnesium, then manganese, after this tellurium, then Ag+, then cesium 2 plus. Then the next thing is the cesium, after that rubidium, after rubidium potassium, after potassium the next one is the NH4 plus, then after this is the Na plus, and after Na plus H plus and Li plus. So what is this? It is nothing but the sequence of the ions by which you can increase the retention time in case of the cation exchange chromatography. Now after this, the next is the how you can increase the retention time of an anion exchanger. You can also increase the retention time by the anion exchanger if the counter ion is exchanged by the another ion. So what is the sequence for this? We will study. This is the sequence for the cation exchanger to increase the retention time. Now the next is how you can increase the retention time of an anion exchanger. It can be increased by using the following sequence. So what is the sequence for increasing the retention time of the anion exchanger? This we will see. So here you are replacing the anion with another counter ion. So the sequence is, the first it start with the citrate. After the citrate, the next is the sulfate. After the sulfate, the next one is the oxalate. After the oxalate, the next thing is the tartarate. After the tartarate, the next thing is the iodine. Now after the iodine, next is the borate. After borate, nitrate phosphate. Nitrate, phosphate, chromate, bromide. Bromide, then next is the bromide. After the bromide, chloride, formate. Chloride, then formate, then acetate. And fluoride. So this is the sequence for the retention time of the anion exchanger. Now after studying the sequence for the anion exchanger and the cation exchanger, the next important thing is what are the special possibilities of the ion exchange chromatography. This is the next point. So the ion exchange chromatography separation, it is influenced by the number of factors. For that we have to first consider the cation exchanger, anion exchanger, then what is the sequence of the counter ion in order to increase the retention time or the retention behavior of the different columns. Now this retention time or the retention behavior, it can be influenced or it can be operated. So the components which cannot be analyzed by using simply the ion exchange chromatography, at that time you have to consider the special cases. For example, if you want to do the analysis of a strong acid or a strong base, then at that time you will prefer for the ion pair type of a chromatography. So ion pair type of a chromatography or reverse phase chromatography, ion pair type of a chromatography or a reverse phase chromatography or size exclusion chromatography, all these are nothing but, or ligand exchange chromatography, all these are nothing but considered as the special cases or the special possibilities of the ion exchange chromatography. So the substances where the normal ion exchange chromatography is not in use, at that time special possibilities are used. For example, the heavy metal cations, they can be analyzed by using the ion exchange chromatography. Sometimes the ligand exchange reactions are also carried out. The strong acids and strong bases which cannot be analyzed by the normal ion exchange, they can be analyzed by using the ion pair type of a chromatography. For the analysis of certain compounds, sometimes the reverse phase chromatography is used. Particularly for the analysis of organic acids, bases and the carbohydrates, the special possibilities of the ion exchange chromatography are used. Now, for the analysis of carbohydrates, you can make a complex with the calcium, and by making the complex with the calcium, the carbohydrates, they can be analyzed in this case. Okay, so this is all about the discussion of the special possibilities of a ion exchange chromatography. Now, size exclusion chromatography, in this case it completely depends on the size of the analyte ion as well as the counter ion. So here the separation is based on the size of the particle. So the size, it plays a very important role in case of the size exclusion chromatography. So today we will stop here. After this we will see the applications and the practical hints used for the ion exchange. Thank you.